Today we're going to solve nonlinear systems of equations graphically. By the end of this video, you'll be able to solve nonlinear systems of equations, including both linear quadratic and quadratic-quadratic systems graphically. Before we get started with nonlinear systems of equations, let's review linear systems of equations that you should have learned in Algebra 1. So this first example gives us two lines, and we're asked to graph them and then find the solution to the system. So let's start by graphing. The first equation is y equals 3x plus 1. So we're going to start at 1 on the y-axis, and then from that point go up 3 and right 1, down 3 and left 1. So that's our first line. That's this one. Then the second line is y equals negative x plus 5. So we're going to start at 5 on the y-axis. Then our slope is negative 1, so we're going to go down 1 and right 1. And then draw our line. Then the solution to the system is wherever the two lines intersect, which is right here at the point 1, 4. If we look at our second example, our first equation is y equals 2x plus 3. So we start at 3 on the y-axis. Then our slope is 2, so we're going to go up 2 and over 1, or down 2 and left 1, and draw the line. Our second line is y equals 2x minus 2. So we're going to start at negative 2 on the y-axis, and then we're going to go up 2 and over 1 since our slope is 2. And we're going to draw our line. So again, we're supposed to look and see where these two lines intersect, and that will be our solution. But they don't seem to intersect anywhere because they are parallel lines. That means we have no solution. So hopefully this helps you remember what you did in Algebra 1. So now we're going to step it up and look at nonlinear systems of equations. We said that a solution to a system of equation is where the two graphs intersect. So when we're talking about nonlinear systems of equations, we don't just have lines. We could have parabolas, we could have circles, we could have ellipses, which are ovals. We can have a variety of different graphs. So we're going to look at these few graphs given here and look and see how many solutions these systems could have. So the first one with these two parabolas, they don't seem to intersect anywhere. So this looks like it is no solution. The second graph, they intersect at one point there, so this has one solution. The next graph, the line and the parabola intersect at 2 points, so there are going to be two solutions to this system. The next graph, the circle and the parabola intersect at 3 points. And the last one, the circle and the parabola intersect at 4 points. So there will be 4 solutions to that system. So in linear systems in Algebra 1, you either had one solution, no solution, or infinitely many solutions. With nonlinear systems, we could have no solution, 1, 2, 3, 4 solutions, or we could have infinitely many solutions as well. So we're going to start by solving this system by graphing. So this first equation is a parabola written in standard form. So I'm going to show you how to do this by hand, and then I'm going to show you how to do it on the calculator. So when we graphed in standard form, there were a couple things we looked at. We had to find the vertex first, which meant that we needed to do negative b over 2a, which in this case, a is 1, b is negative 2, and c is negative 6. So if we have negative negative 2 over 2 times 1. So that just gives us 1. Then we need to plug that back in for x to get the y value. So we have 1 squared minus 2 times 1 minus 6. So that gives us 1 minus 2, which is negative 1, minus 6, which is negative 7. So our vertex is 1, negative 7. So we'll go ahead and graph that. Then our a value is 1, which means we're just going to follow the standard pattern for a quadratic. So we're going to go over 1 and up 1, over 2, up 4, over 3, up 9, and then the next one would be over 4 and up 16, but that won't fit on our graph. So we can go ahead and draw this parabola. Then our second equation, we have y minus x equals negative 2, which is a line. And I'm going to go ahead and solve this for y, and then graph this equation. So our y-intercept is negative 2, and then our slope is 1, so we're going to go up 1 and over 1. Then we can draw the line, and look and see where the two graphs intersect, which there are 2 points. So our solutions are the point negative 1, negative 3. And then if we look at our second intersection point, that's the point 4, 2. So those are our solutions. And we can check our answers on the calculator. So you want to go to y equals, and you want to graph these equations. Our first one is already in y equals form, so we can just go ahead and type it in the calculator. Then our second one, we already solved for y, so we can just type in x minus 2. Then we're going to graph them. So you can see that we have a parabola and a line, and that they intersect at 2 points. If you want the calculator to give you the exact intersection points, you can do that. You just need to click Second, Trace, Intersect. Then it'll give you prompts down here. So you want to make sure that your cursor is on the first line that you're finding the intersection of. Hit Enter. Then make sure it's on the second line. Then guess, you want to have your cursor near the intersection point, so we can go ahead and hit Enter. And that gives us negative 1, negative 3 as our intersection point. If we want to find the other intersection point, we follow the same steps. Second, trace, intersect, first curve, second curve. And then when we get to guess, we need to scroll over and make sure we're closer to that second intersection point. And it gives us 4, 2. Let's take a look at another example. It says solve the following system by graphing, and it gives us, in this case, 2 quadratics. The first one is in intercept form. So we know that our x-intercepts are going to be negative 2 and negative 6. So we know that our axis of symmetry is going to be x equals negative 4. So we're going to use that when we find our vertex. So we need to plug negative 4 in for x. And we get negative 2 times 2, which is negative 4. So our vertex is negative 4, negative 4. So if we fill in our other points, we go over 1 and up 1. We already have over 2 up 4. We can go over 3 up 9. And then we can draw our parabola. Then for the second equation, This is in vertex form, so this should be pretty easy to graph. Our vertex is going to be -4, -4, because remember you always switch the sign of h. You have A, H, K. So our vertex is going to be -4, -4, which is the same vertex as the other graph. And then A is 1, so we're going to follow the normal pattern for a quadratic. We go over 1 and up 1, over 2, up 4, over 3, up 9. And you can see that we're going to end up with the exact same parabola. If you ever end up with the two graphs being identical, then that means you have infinitely many solutions. And again, we can check this on our calculator. If you go back to y equals, delete the previous equations, and type in these two. So we have x plus 2 and x plus 6. Then our second equation is x plus 4 squared minus 4, and graph. So we have our first graph, and then our second graph is the exact same line. So yes, we do have infinitely many solutions for this example. One last question. You might see questions like this where it says determine the solutions from the graph of the systems below. This means that you have way less work to do because all you need to do is look at the graph that's already done for you and find the solutions. Remember, solutions are where the graphs intersect, so we have a circle and a line, and they intersect at 2 points. I know it's a little bit hard to read these numbers, but you have 3, 5, and -3, -4. So those are your two solutions.